Hi everyone, Luke Stein here. This short video is going to introduce a third key capital budgeting decision-making tool called the payback period. The idea behind the payback period is that we're going to figure out how long it takes for a firm to have received back all of the cash that it initially put into the project. And as I lay out that question, you can probably tell that it's going to ignore explicit treatment of the amount of risk that's involved in the project and the time value of money. All we're going to be asking is, does the project get back the cash that they put in, or does the firm get back the cash that they put into the project, and how long does it take for them to get that cash? So, payback period. We have been asking a few key questions as we try to make capital budgeting decision making. The first is, how much money does a project make? Taking into account risk and the time value of money, we're going to use the net present value tool to do that. A second question, what is the rate of return that a project delivers? That's going to be the project's internal rate of return. And we're going to make decisions about whether or not to invest in the typical investment project, one where all the money that goes in at the beginning and all the benefits come later. We're going to make those decisions either by looking for NPV positivity or for an IRR, which is greater than the firm's hurdle rate, typically its cost of capital. The third question that we're going to ask is about payback period, and that is the simple question, how long does it take before the firm recoups its initial investment in the project? What's nice about this tool, and the reason that it's as commonly used as it is it's super easy to calculate. There is only addition, subtraction, and division involved. No exponentiation. You can typically do this without Excel, although we will use Excel. You can sometimes do this with mental math. Certainly you can do it with a 4-function calculator. So let's take the simplest possible example. Suppose that a firm puts $100 million into a project. It does that today. That's the initial outlay. There's a time zero cash flow of a negative $100 million. And suppose that the cash flow benefit of doing the project arrives 2 years later, and that project, that benefit is a positive $120 million cash flow. So if you think about traveling through time, starting at today the firm has put in $100 million. They have not yet recovered that money. So let's step forward one period. Let's call it 1 year. 1 period from now, the firm has not yet seen any benefit from the project. That means that they are still $100 million below where they started. They have not yet recovered their initial investment. The project has not yet paid back. Step ahead one further period. We are now at time 2. And in time period 2, or in, let's say, year 2, the project delivers positive $120 million. That's more than the $100 million that the firm put in to do the project initially, and so it has now paid back. So what we can tell just by doing some simple comparison of the numbers is that within 1 year, the project has not yet paid back, so the payback period must be bigger than a year. Within 2 years, the project has paid back, and in fact, it's paid back a little bit extra. So the firm must have gotten paid back somewhere before the end of year 2. So how long is the payback period going to be on this project? Well, it's going to be somewhere greater than a year and somewhere less than 2 years. So how much is it going to be? Well, we can go to Excel and we can note that at the end of 1 year, the firm has recovered nothing. And at the end of 2 years, it's recovered $120 million. How much does it need to recover? Well, it needs to recover $100 million. So how long out of year 2 is it going to take to do that recovery? Well, they've got to get $100 million. They're recovering $120 million a year, or $10 million a month. That means that it's going to take them 10 months, 10 out of 12 months, or approximately 0.83 of that second year. So how long is their payback period going to be? Well, it's going to be the 1 year that they got nothing, plus the 0.83 of the second year that it took them to get the $100 million they needed. The payback period on this project is going to be 1.83 years approximately, or 1 year and 10 months. So that's how we're going to do this kind of calculation. So let's move to a slightly more complicated example. And we're going to calculate a payback period on a slightly more complicated project. But again, when all the money that goes in at the beginning. So the initial outlay is negative, and then all of the future cash flows are positive. And what are we going to do? Having calculated that payback period, we're going to apply a payback rule that says, accept any project that pays back the initial outlay sufficiently quickly. How quickly is quickly enough? Well, Firms are typically going to apply some kind of required payback rule. And where does that come from? Often a rule of thumb. So the firm may say, we will do any project that pays back within 4 years, or we'll do any project that pays back within 7 years, or we'll do any project that pays back within 2 years. So typically ad hoc. How are we going to calculate the thing? So what do we just do in Excel in more general terms? The payback period is going to be the number of years that have passed before the firm fully recovers. So in our earlier example, there was 1 full year before full recovery. And then we're going to try to figure out what fraction of the last year it's going to take in order to recover by figuring out how much more money the firm needed to recover in the last year divided by the total amount of cash that they recovered during that year to figure out what fraction of the year it takes them to get that recovery. So how long does it take to recover the funds invested at the start of the project? The implicit assumption that we're making is that in the last year, the funds are arriving continuously over the course of the year. So if they need half a year's worth of funds, it's going to take them 6 months to get it. A shorter payback period is better. How do we set that rule? I don't know. We just guess. That's part of the reason that this tool is not typically a good one. And often is just used as sort of a very rough first cut mental math that managers can do around the meeting table, even just in their heads or pulling out a calculator, really does play a role, but should not probably be your principal decision-making tool. So gives you an idea, is this kind of a slam dunk that shows up green? Is this really terrible, which might show up red, meaning a very long payback period? Or if it has some intermediate payback period that seems reasonable, then you might actually bust out Excel and a fuller model to calculate IRRs and or NPVs. So let's take a classic simple example. This is a 3-year project, but given that it requires an initial investment starting in year 0, we're going to see 4 years worth of cash flows in year 0, 1, and 2. And those cash flows involve negative cash flows in year 0 and year 1, totaling $170 million to get the project started, and then benefits that start to arrive in year 2 and continue into year 3 before the project is over. So the key math that we could even do mentally, although then we'll do it in Excel, is to recognize that the initial outlay involved in the project is $170 million, and that happens over the first 2 years. Year 0 and year 1. Then in year 2, the firm has only recovered $170 million. So comparing $150 million. So comparing that 150 to the 170 that they need to recover, they have not yet recovered. We know the payback is going to be somewhat longer than 2 years, and we can make that calculation a little bit more explicit by just adding up cumulative cash flows. So cumulative cash flows are going to involve just adding up the cash flows as they arrive, the negative $100 million in year 0, plus the additional $70 million outlay made in year 1, means that the firm has done $170 million in total outlay by the end of year 1. Then if we add the positive $150 million that they generate in year 2, they are still negative 170 plus positive 150, $20 million behind where they need to be to fully pay back. So we know that the payback period is going to be longer than 2 years because they've not yet fully paid back at the end of 2 years. But in year 3, they're going to generate a positive $100 million cash flow. That 100 is greater than the negative 20 or the 20 that they needed to recover still to pay back on the project. By the end of year 3, they would have positive cumulative cash flows. So they've more than recovered their entire initial outlay. And again, if we wanted to try to do this with mental math, the comparison we just need to make is between the negative $20 million that they are relative to where they started by the end of year 2. We got that by just adding up the year 0, year 1, and year 2 cash flows cumulatively. We're going to compare that with the cash generated in year 3. And given that year 3 generates $100 million and they only need to recover $20 million in order to hit payback, that means that they should only need 20 out of 100, or 1/5 of that third year, to have totally paid back on the project. So what's the payback period going to be? It's the first 2 years during which they've not yet recovered, plus the additional 1/5 of a year, the 1/5 of year 3 that it takes for them to recover, for a total payback period of 2.2 years. And that's pretty quick. So maybe the firm is going to decide to do this project given that payback period. So if we wanted to do that in Excel, we could move over into Excel and take back our classic first example. We've talked about in earlier videos about how to calculate the IRR or the NPV on this project. If we wanted to calculate the payback period, all we need to do is add up cumulative cash flows. And there's a couple different ways that I can program that in Excel. One way that I can do it is just by starting with the $100 million in year 0. So that's going to be a standalone formula. And then for each additional year, I'm going to add up whatever the cumulative cash flows were at the end of the previous year with whatever the new cash flows are this year. So in year 1, I started year 1 with the negative 100 that I had from year 0, and then I'm going to add the additional negative 70, which brings me down to negative 170. And then if I just copy that formula to the right, I'm going to add positive 150 in year 2 to the negative 170 that I had from the earlier years, and that's going to mean that I'm at negative 20 overall. And if I continue to copy that formula to the right, I get the positive 80 that I have at the end of year 3. If you'd like to see another way to do that same math, I could instead do this by using the sum function. And so I could do a sum, which is a cumulative sum that includes all of the cash flows up to the year in question. And then I'm just going to make sure that I lock in with dollar signs in Excel that column reference, in this case, column C, so that my sum always starts with the year 0 cash flow. And if I copy that formula to the left and the right, what I'm going to do is I'm always just going to be adding up a sum that includes cash flows starting from year 0 up to the cash flow that I'm considering in this year. I'm going to get the same answer either way. So how do I calculate the payback period? You may sometimes see, including in solution spreadsheets or people who write very, very fancy if-based formulas. So if we haven't recovered yet in year 1, let's check year 2. If we haven't recovered yet in year 2, let's check year 3. Those things are very robust to making significant changes in assumptions, but they also tend to be very, very hard to code and very, very hard to read. So the simplest way to do this calculation, although it's not going to be robust to changing assumptions later, so it's not going to create a very flexible, kind of long-lasting Excel spreadsheet, but if you want to do this a quicker way, all you need to do is just look for the place where the cumulative cash flows cross over from being negative to being positive. And so I know that the answer on payback period has to be somewhere greater than 2, where cumulative cash flows were still negative, but less than 3, where cumulative cash flows had turned positive. So what am I going to do? Well, my payback period is going to be equal to 2, plus how much more cash do I need to recover? Well, I need to recover another 20 to pay back, but in year 3, I'm recovering 100 per year, which means I'm going to need what fraction of a year? I'm going to need 20 out of 100. And the only thing I need to be careful about there is this 20 is a negative 20. And so if I hit enter, I'm going to get the wrong answer. Instead of getting 2 years plus a fifth of a year, 20 over 100, I'm going to have 2 years minus a fifth of a year, because negative 20 over 100 is negative a fifth. So one thing I could do is I could put in a minus sign here instead, and I'll get the right answer. But another way that you'll often see folks do this is what they'll add is the absolute value. And Excel has a function called ABS, which is the absolute value. And the absolute value function is just one that always turns a negative number into a positive number while also leaving a positive number as a positive number. So different ways to do this, but if you see this ABS, all that is happening in the background is we're doing equals 2 plus 20. That's a positive 20 rather than the negative 20 we're seeing in cell E3 for cumulative cash flows, divided by 100, which is the cash flows being generated in year 3. That's cell F2, and that's going to give us the answer of 2.2 years. So a quick note about advantages and disadvantages of using the payback period. It's easy to understand. It does place more priority on earlier cash flows. And for firms that don't necessarily have a lot of capital to invest in projects, it may be really important for them to recover all the cash that they put into one project before they can go out and start the next one. However, it ignores the time value of money beyond just applying an arbitrary cutoff period. So basically it says, if you use, let's say, a 3-year payback cutoff, it says, I don't care whether the payback comes in year 1 or year 2, the cash flows come in year 1 or year 2. All I care is, are they before or after year 3? So you take a project that pays back, but pays back slowly, and even if it gets an extra million or billion or $1 trillion delivered in a couple years, payback period is going to say, I don't care. I don't care about anything that happens after the arbitrary cutoff period. All I care about is, do we get back the money we put in quickly enough? So projects which generate very, very large, significant long-term returns may look unattractive under a payback period-based rule.
Dollar, dollar